Picture this. You're asking an AI assistant for the latest medical guidelines, but instead of "I don't know," it gives you accurate, well-sourced information from recent studies. That's the power of Retrieval-Augmented Generation, which abbreviated into RAG. Hey everyone, welcome back to the channel where we decode the most exciting tech breakthroughs. Today, we're diving into how RAG is revolutionizing AI's ability to handle complex questions and generate hyper-accurate, natural-sounding responses. But how does RAG achieve these incredible things? As shown in the research paper, RAG uses two key players. A retriever, like a super-efficient librarian, fetching the top K relevant documents. A generator, a creative writer, transforming those facts into meaningful answers. A knowledge base, an indexed repository of external documents. And guess what? These components are pre-trained. Therefore, RAG doesn't just learn, it builds on a massive foundation of knowledge. However, do you think that's all the magics? Here's where RAG gets even cooler. As shown in the figure from the paper, it doesn't always rely on the same approach. RAG sequence uses one document for an entire answer. This is simpler and more computationally efficient, but less flexible for tasks requiring diverse sources. RAG token is a multitasker, pulling facts from multiple documents as it generates each word. This approach is more flexible and allows the model to aggregate knowledge from multiple sources, but is computationally intensive. Think of it like baking a cake. Sequence mode sticks to one recipe, while token mode grabs tips from different cookbooks. Therefore, the system marginalizes all retrieved documents during training and inference. Here's an example of the workflow of RAG. Input. Query. Who is the President of France in 2024? Step 1. Encode the query into a dense vector. Step 2. Retrieve the top K documents from a knowledge base, such as Wikipedia. Step 3. Pass the query and retrieve documents to the generator model. Step 4. Generate the response. The President of France in 2024 is Emmanuel Macron. Even though traditional AI models know what they were trained on, they are not suitable for knowledge-intensive fields like law, medicine, or research that require up-to-date and accurate information. Therefore, here's where RAG steps in. By integrating retrieval, these models could stay current with the latest data, reduce the risk of generating outdated or false information, and scale knowledge access without ballooning memory or model size. But how does RAG actually perform? According to the research, it consistently outperforms traditional generative models in knowledge-intensive tasks. Let's break it down. The study shows that RAG achieves a significant boost in accuracy when responding to complex questions. It even achieved state-of-the-art performance in many aspects. For example, it demonstrated higher scores in benchmark datasets like natural questions and trivia QA, where retrieving the right information is critical. By fetching the necessary information, RAG generates more factual responses comparing to other methods. As shown in the research paper, RAG generates more reliable responses. RAG's ability to retrieve real-time, contextually relevant information improves user trust. Users reported higher satisfaction with answers generated by RAG in tasks requiring updated or niche knowledge. Therefore, RAG doesn't just promise better performance, it's delivering. But RAG systems face several issues and limitations, including a dependency on high-quality retrieval mechanisms, which can introduce noise or irrelevant information if the retriever fails to prioritize accurately. They are computationally expensive, especially when retrieving and processing large volumes of documents. Excessive reliance on retrieved data can lead to reduced robustness if the knowledge base is incomplete or outdated. Furthermore, integrating retrieved content seamlessly into generation remains challenging, often requiring complex marginalization techniques that increase latency. Therefore, these challenges highlight the need for optimization in retrieval, reasoning, and system efficiency. But there exists an easy solution to some of these issues: combining RAG with model fine-tuning. To be more specific, there are roughly 4 scenarios that we use large language models. Regarding the first scenario, we can use Retrieval-Augmented Generation to leverage continuous and up-to-date external knowledge sources. That makes it an effective strategy for dynamically retrieving and grounding outputs in reliable, current data. Regarding the second scenario, we can use model fine-tuning on optimizing the internal parameters of the LLM, which effectively embed domain-specific knowledge within the model itself. By tailoring the model's weights to reflect the unique language patterns, terminology, and reasoning processes of a particular industry or application. Therefore, model fine-tuning creates a smarter and more specialized LLM. Regarding the third scenarios where explainability and source attribution are crucial, such as in healthcare or legal contexts, we can use retrieval-augmented generation to optimize the output. The ability to cite sources not only ensures factual accuracy, but also enhances trust and transparency. Therefore, it enables users to verify the generated output. Regarding the fourth scenario, when analyzing historical or static datasets, we can use model fine-tuning, as it optimizes the model to understand and generate insights from a fixed body of knowledge. In such cases, the static nature of the data makes retrieval unnecessary. However, even if it sounds like a decent solution, it is way too complicated to apply this to real life. How could AI categorize all tasks into these four groups? What about some tasks that belong to multiple groups? How to effectively deploy this LLM system? In fact, most RAG systems treat retrieved documents as isolated pieces of information, completely overlooking the relationships between entities. They falter when dealing with structured or hierarchical data, like knowledge graphs or ontologies, because they're designed for unstructured text. This leads to fragmented reasoning, especially when multiple sources offer related but slightly different insights. That's all because RAG relies heavily on direct similarity measures for retrieval, which struggle with ambiguous queries or ones needing contextual refinement. Multi-hop reasoning is another major hurdle. Let's not forget also, RAG systems often retrieve irrelevant or redundant documents, making coherence a constant battle, especially when faced with overlapping or conflicting information. How to solve these issues? Is there any hope for RAG? Anyways, RAG is redefining how we think about AI. In the next video, we will explore innovative ways to overcome these issues and unlock more potential of RAG in the age of advanced LLMs. Trust me, you won't want to miss it. But what do you think? How could this technology transform your industry? Drop your thoughts in the comments below, and don't forget to like this video and subscribe for more deep dives into the future of AI.